I am Austin Mason. I'm at Carleton College, and I'm really thrilled to be moderating this panel today on a topic that is near and dear to my heart, which is digital imaging of objects, 3D models, and a really interesting and innovative collaborative project coming out of Williams College on those topics today. So we have Beth Fisher, postdoctoral fellow in digital humanities at Williams, Amber Orozco, who's an MA candidate and the academic programs intern at the Williams College Art Museum. And she's in the Williams College Art History graduate program. And Liz Gallerani, who's the curator of Mellon academic programs at Williams. They'll be speaking to us about this collaborative project with a paper titled Up Close and Personal Art Museums and Digital Models.
Thanks very much for that introduction, Austin. I'm going to share my screen now. And throughout this, we'd love to encourage you all to speak up if you have something to add to the comments. Throw it in the chat. We might not get to it till the end, but we also want this to be conversational, as we know a lot of other institutions are working on this kind of project, and we'd love to hear your thoughts on it. I'm Beth Fisher. As Austin mentioned, I'm the postdoctoral fellow in digital humanities at WICMA, which is the Williams College Museum of Art. And that means my role is really centered on digital resources in general, and particularly on teaching with the museum's digital resources and about visual approaches to digital humanities more generally. So I spend a lot of time in a teaching role, and I'll pass it over to Liz.
Hi, everyone. Thank you for joining us this afternoon, or depending on your time zone. My name is Liz Gallerani. As Austin mentioned, I'm curator of Mellon academic programs at the Williams College Museum of Art. I've been here about 14 and a half years, and my job is really to help integrate art into teaching and learning across the discipline, working with art studio across the spectrum into the math and sciences, always approaching it through the lens of that specific discipline. I'll pass it to Amber.
Hello, everyone. My name is Amber Orozco. I'm my first year in the Williams College graduate program in the history of art, and I'm also the graduate intern in the academic engagement programs working with Liz this year.
So this is a view here of the Williams College Museum of Art. Our eye is on the undulating lawn that were a commission by Louise Bourgeois, a contemporary artist. And situated right in the middle of the Williams College campus, as many of you might be familiar. So as we gather in this digital space, we wish to acknowledge that our campus and its wealth are built on a legacy of displacement of Indigenous Mohicans peoples. Williams College, our employer, and within which WICMA is included, resides on the ancestral, spiritual, and unceded lands of the Mohican elders, past and present. Despite tremendous hardship in being forced from here, today their community resides in Wisconsin and is known as the Stockbridge-Muncie community. We pay honor and respect to their ancestors as we commit to building a more inclusive and equitable space for all. Such an acknowledgement about the past of place, while important, is only a gesture without continued present-day action, learning, relationship building, and collaboration with Indigenous communities, work that we are taking part in and continuing to deepen. Work that also takes time and requires slow and deliberate reflection, enduring action, and continued care. We also encourage you to consider and learn about the histories of the land you are on. We will drop links in the chat to some helpful resources.
So first off, what are we doing and why? This is a digital imaging project that was brought about to both test what new imaging types could tell us about our collection, but especially to think about how these imaging types could be used in teaching and how the processes behind them could be brought into teaching across the curriculum. We thought this was a fun way to think about how we interact with art, but also a way that would give students more agency and more of a say in a lot of parts of the museum that they don't normally have access to for a variety of reasons. Our primary imaging types in this first phase have been photogrammetry, creation of 3D models that I know many of the LACOL institutions are working on, as well as RTI, or reflectance transformation imaging, which is a way of working with light to produce an interactive model. And our goal throughout wasn't to make the most precise simulacra of objects in the sense of wanting something that can substitute for seeing an object in person. Throughout, we really envisioned this as an adjunct to visiting the museum in person, and we expect to continue that in person. and have students going back and forth and having this be an additional way that they interact with physical works of art. That means we focused on minimal equipment, flexible locations, and streamlined processes. And it's just really, I think, again, part of this idea that the making of digital resources is a key part of a liberal arts education. And so we didn't just want to provide finished models. So critical thinking, close looking, and just having fun with our collection in many ways, and maybe bringing attention to some of the works in our collection that are less noticed as well. So we'll be talking a little more today about how we have done this and the kinds of models we've chosen to focus on, but also how we're using these models in teaching and the processes in teaching, and then some of the opportunities we're working with across our campus and hopefully with other institutions.
So in terms of the project goals, DEIA, or diversity, equity, inclusion, and accessibility, was really at the core. So really thinking about data bias. We're huge fans of the data feminism book, range of makers, range of audiences, and as Beth mentioned, bringing more attention to underused objects. And again, those could be objects that haven't been exhibited much, and or objects that haven't been used for teaching as much, for spaces such as our classroom space. We wanted to focus on the objects used frequently for teaching, also trying to anticipate some of the teaching needs across the campus. An opportunity to carry forward that even though Williams is committed to an in-person fall, we want to continue to use these models. And so we'll be talking about that today. Really encouraging student agency, exploration, play, and curiosity, enabling them to manipulate models in ways that we really don't want them to touch the actual objects. Also thinking about increasing comfort levels with objects, really breaking down if it's town and gown barriers, if it's thinking about, museums as sometimes intimidating places, white cubes, who is it for? Are we welcome there? So really trying to break down some of those barriers. Also training students to create their own models, not only teaching with ones that the three of us have made, but really involving students in the process throughout, as you'll be seeing today.
As many museums did, we started in the space of sharing exhibitions and sharing static resources. We were lucky that we'd been working on data for a fair amount, particularly the metadata around our collection, but also image sets as data in themselves. And then we added Matterport 3D exhibitions as a way of promoting student access to these spaces when we closed and thinking about the spatial arrangement of objects. But at the beginning, this was very much focused on a sort of one-way communication. There was, you could explore an exhibition, but you couldn't really contribute to it. And it wasn't part of this sort of generative collaboration that we've been moving toward. So our approach now, we still use things like Matterport, we've added other imaging types, but now we're really thinking about all of these digital resources as places for connection and communication, and Matterport particularly has become an important hub for us for gathering together different resources, not just as a presentation tool.
And so an exciting pilot that we did was using Matterport as the exhibition hub for Tasvir Khanna exhibition of Indian paintings that I co-curated this spring with Professor Murad Mumtaz from the Williams Art Department. So this exhibition provided an active studio space for his studio art class of 10 students, and actually in the class and was the TA. So it was a very helpful link between the class and the museum. All students were actually on campus. We weren't sure if any students would be remote or hybrid. And they were in the gallery 1 to 2 times a week. So having 19 visits total. For museums, this is a very big deal to use a gallery as an active studio space with ink and water and things that museums typically don't want in their gallery spaces. So this was an excellent opportunity for us to pilot this. So in terms of being an exhibition hub on the website, this Matterport integrates high-res images of the works of art in the exhibition. So you can see that in the top right here with this beautiful flower study. It integrates digital imaging models that we made, exhibition labels, information about the class use, the fact that they were actually sitting on the ground as you would in a typical Indian workshop at that time, with backboards behind them. And it also incorporated 16 related class videos, including an exhibition intro, 2 public programs that we had done in a virtual setting, and also a series of instructional videos where Professor Mumtaz was talking about how to prepare different materials, like you can see in the bottom right here, preparing different pigments. This past year, WICMA was open for class use only on campus, but we were closed to the public. So Matterport provided an opportunity for us to open up in digital spaces to a far wider audience. Moving forward, as we reopen, this will continue to be a useful tool for bridging audiences and making resources more accessible.
So on to the imaging types we've been exploring. The first is photogrammetry, and I'm going to guess that a lot of this audience is familiar with at least using photogrammetry models, if not creating them yourselves. But photogrammetry is a way of taking a whole bunch of photos. I usually do somewhere between 120 and 200 per object, and stitching them together, sort of a reverse panorama or a panorama turned inside out. And this produces a 3D model that can be explored on a computer in a browser to get a sense of a lot of the sides of an object that aren't visible even when it's installed in a gallery. And again, to allow students to do their own tours of the object and to annotate them. So this gave us a much better way of allowing close looking. As I mentioned in our introduction, we really focused on setting up this process in a way where we could have students doing this themselves. Although it requires direct object presence, it doesn't necessarily require much touching of individual objects. So as long as you have someone present who can handle the object positioning, students can do a lot of it themselves. The key components are decent lighting, and that can be in natural lighting if it's good enough. A way to stabilize your camera, but you can actually do this with an iPhone camera just fine, as long as you have manual control. And then a piece of software, and there are open source software packages, although we did use Metashape, which I'll talk about in a moment. You can see here 2 of the places that we shot. With museum access limited and some spaces off limits due to size constraints for how many people could be in a space, we've been working in a variety of different spaces. So on the left, I'm in our object study gallery with sort of our biggest version of our setup, a light tent, studio lights, things that we actually already had on site for other kinds of photography. And then on the right, I'm working in our digitization studio because we had objects that couldn't be set up upstairs in our study gallery. So very flexible. We've also shot in the galleries and can shoot in classrooms and things like that as well. I mentioned that after you take the photographs, you stitch them together in software. And I'm showing this part because I feel like this just is the epitome of what photogrammetry is all about, both in terms of how the software works to combine photographs into a point cloud and then into a digital model, but also in how this works for close looking, setting up these shots, realizing what angles you need to get to capture the work of art. And really seeing it from points of view that you wouldn't think to look at because they might not immediately strike you as important. All of a sudden, all of the shadows get more important. All of the gaps and negative spaces and complexities become very apparent. You notice surface detail more. Liz has been looking at some of these objects for, I forget how many years, more than a decade. And when she's doing photogrammetry with me, she'll point out things that she hasn't noticed before using these objects in teaching. So we actually bring this image to classes when we teach, so that even if they can't do the process themselves, as has been true for most of our remote teaching in the past year, they can understand why there are choices made in this, and this is not an automated process.
So in terms of teaching applications, as Beth has mentioned, photogrammetry models help you see things that you can't see, sometimes with the naked eye, sometimes also with an installed object. This particular one here was on view in a gallery behind plexiglass and up a little bit higher on a pedestal, installed with 2 other objects. So you couldn't go all the way around the object. Students can freely manipulate the model. So this is a pre-recorded video of Beth moving it around. For example, seeing the inside of this vessel like we are now, this was an incense burner. And so as students are thinking critically in this anthropology class this past year, all about Maya civilization, they needed to think about the use of the objects too. So why are there these holes on the sides? Was it ever actually used for burning? And so one of the first things that they'll do is try to look on the inside, which is almost sadly impossible due to the way that we need to safely install the object. So being able to see all these different angles, like the inside of the object, or maybe the very bottom of it, really encouraging that student agency, the play, the ownership even over an object. So we had made this model to prepare for a particular class, and all students were actually on campus. We had thought, again, that some of them might be off campus, and so really anticipating some hybrid use. And they used the model after visiting on site. And so it was a really great case study for us to see, again, moving forward, what's this combination between being on site with the actual physical object, and then how can that complement and be enhanced by this student manipulation of different models. And so really trying to stress to our colleagues, this is not replacing being with the actual object. They each have very different experiences for students and couple together in such a strong way. And so really being able to see how this can be used moving forward, combining the in-person looking with exploring the models offsite.
Right now, we're primarily using these models as standalone teaching tools in a variety of classes, but we're expecting to be using them more in other ways. So for 3D printing, for example, I'm also looking at using them in gaming environments, whether that's Unity or Unreal, or even custom-built WebGL frameworks. So for example, for objects that have moving parts, we would be able to make that more interactive. So we're seeing some possible additional things we could be doing in the future. And if anyone is exploring those, we'd love to hear some ideas for that. Primarily right now, we share these through a platform called Sketchfab. And I know that several LACOL institutions have a presence on Sketchfab, along with many, many other museums. And so this is a great way where we can provide an easy to use platform. And we not only allow people to view the finished models, but we also allow them to download all of the resources that went into creating them. They can get the photo sets through our campus archive, but they can download the point clouds and the textures and pieces like that from Sketchfab. They can also directly embed these, if faculty want to or students want to, they can directly embed these in their own projects to use them themselves. And we're starting to work with that as well. So we want people to be using these, not for this to be an end product in itself.
You can also see from this screenshot that Beth had taken the range of objects, makers, cultures, time periods, and materials for these photogrammetry models that we've been creating. So we started with smaller objects like the one that you just saw on the previous slide that's in the bottom left here, that were easier to photograph, especially as we were buying some better equipment and learning getting the hang of it ourselves. And then working up to larger, more intricate works like the mask that's towards the middle that we'll be seeing in the next slide, where there was far more kind of crevices. It's much more difficult to really get a full model from all the photographs that you're taking. So again, prioritizing the objects that were being used in teaching or works that we knew would be on view, but also seeking out objects that haven't been used as much and that we have limited cataloging data for. So Beth and I both participated in a Zoom session for a fully remote course this past spring, a theater class, Why We Put on Masks, Theater in Practice. This was a brand new course, very timely. And students are thinking about design, wearability, object in motion, and display. Also thinking about their own virtual exhibitions that they created with objects in our museum's collection. So on the left here, you can see how Beth had an idea to creatively use blue person model so that students could explore how a mask was worn. It's something where when we're looking at these when they're installed, when we're looking at them in our object study classroom, we're not moving them. This object is actually quite heavy, so you can imagine what it would be like to perform with it. It's something I'm not moving around. I'm certainly not placing it on my head. That is not best practice. So how would we know how it would be worn? And so being able to slide it around on the model that we see here on the left so that students can get a sense of that. In the center, students were actually able to look through the eye holes of the photogrammetry model. And so again, really thinking about the visibility, the embodied learning here. What would it have been like to wear this mask? What it would be like to perform while wearing it? And so really trying to give that sense as they look through the eye holes here, which is something that, again, they wouldn't get to experience with the object itself.
Those of you who have worked with Sketchfab before will probably recognize that that model is actually intended for setting up virtual reality spaces. So again, that's something we're thinking about as we're teaching more on campus, but also just how can we use these existing tools, third-party tools, in ways that suit us better. So for looking through mask eye holes, for thinking about materiality, we're very interested in the sculptural qualities in human relationships. So I think that that's something where there's a lot of work that all of us can be exploring together. And we'd really love to hear from other people about what they're doing in that way. Getting students started on photogrammetry. This is something we've gotten asked about several times. And we really want to emphasize that a big piece of this is about how creating the models is as important as the final product. And we don't wait until we can do a perfect model. We've modeled works that, like, if I were choosing to make something for a 3D model, I wouldn't have tried to do because of the kinds of mounts that we're working around, because of the materials, because we actually think that the process of where models fail tells you as much as making a perfect, precise model. What can you tell from this kind of tool? What might another tool be better for? Where are there problems or mistakes? Where is the computer doing something, and how is computer vision different than our own vision? That said, I think that this is also telling us a lot about what students are capable of and how much these processes have changed over the past few years and how much more accessible they've gotten. A really key thing for us was support from the rest of the museum staff, and especially our preparators. And I can't stress enough how important that was, not just for the stuff you would expect, preparing objects, getting them into a space, helping you move them around, but because they are so familiar with the fragility and the strength and the details of objects. They think about things all the time that we don't think about until we're doing this kind of approach. Like, hey, let's put that sculpture on a sculpture lift instead of a pedestal so that we can get it from more angles. And you really can't see this one angle unless it's on a lift. So if you are doing this kind of work, I really encourage you to talk to the people who are conservators, things like that, even for something that is so image-based, because it does remind you of the materiality of things that we see in images so much. Equipment and software. We have a handout that we have been using to talk about how to do this kind of work with students. It's really just about what is the lowest barrier to entry? What do you absolutely need to get started with a project like this? And again, this is the kind of thing where a grad student, an individual faculty member, someone like that could take this list and do it themselves without much institutional support. I think as we're ramping up, we're looking for more ways to collaborate across our institution. But when we were getting started and just seeing how useful this was, we wanted to focus on what someone could do without much buy-in from their institution. But again, now we're looking at this. What else can we do? What other applications are there? Where are the opportunities for things like statistical analysis, math classes doing topology work, human-computer interaction studies, all of these other ways that this kind of thing can be used outside that what we initially positioned it to do. And that's where we're really talking to people across campus to see what happens. The other kind of imaging we're talking about today is reflectance transformation imaging, or RTI as it's more commonly called. And this seems to be something that not as many institutions are doing. If you are doing it, I'd love to hear from you because we'd like to compare notes. But this tends to be something that people seem to do more in labs than they do in classroom type spaces. And RTI produces an interactive image file so that you can explore the details of the surface. So where photogrammetry is focused on sort of sculptural, spatial qualities of an object, RTI helps us explore the surface. Things like technique, materiality, wear, damage, things that have to do with how the object was constructed and then its later history. So it doesn't give you a virtual representation of being in front of the model. It gives you an interactive way to almost test different lighting angles or different brightnesses or reflectivity as you work through it, to see things that you might not be able to see in person at all, no matter how much access you had. And I'm going to pass it over to Amber because Amber really had a great deal of ownership over this project and was a driving force behind it.
Thanks, Beth. So yes, reluctance transformation imaging basically allows you to manipulate the object by shining almost a flashlight over it in a digital viewing technology, which we'll get into later. But I initially started working with this technology as an undergrad and was able to train with it really quickly in a short time period. And just because of my interdisciplinary interest in working with the museum and working with objects, and I'm really fortunate to be able to continue that work as a graduate student. But I had absolutely no background in photography, and going into some objects that are really good candidates. On the left-hand side, you can see that I'm working with a small two-dimensional object that has a high amount of line detail. And we actually have some shots in a later slide that show you how beautiful it looks under RTI imaging. But we're in the object study gallery on the left-hand side, but it's not limited to two-dimensional objects. On the right-hand side, we're inside one of the galleries at WICMA, working with a three-dimensional tenon. And it's really interesting to kind of compare the horizontal and vertical setups, but it's a very adaptable technology. And we're able to kind of take it into different areas and different spaces. And as Beth said, it's not necessarily as used primarily in museums, but more for labs. It's used outside. This technology is amazing. And in the next slide, I think we have some awesome shots that Liz is going to talk to us about.
Thank you. So this is what we saw Amber working with in the previous slide, and these are some of the RTI images. And just to see how incredible it looks, especially for all of us looking at it on screens here, what we can actually tell from looking at these closer images. So what we're looking at is a 16th century frontispiece from a Persian book of love poetry. This book has been dispersed like so many others, and so we only have 2 pages from it. This was used for teaching in the spring for another fully remote course, a religion course called Reading the Quran. And so students were able to examine some of these RTI images, some of these pre-recorded videos. And they discussed how the makers interacted with the page, thinking about the thickness of the paper and the paint, especially in cases like the bottom right, where when you look at the object itself, it looks entirely flat. But as you see these still RTI images, it has such a sense of depth. There's so much 3D to the way that the paint was applied. You can see horizontal line rulings. I'm one of those lefties that always goes downhill. So really appreciating this workshop process too, that this wouldn't necessarily be one person creating this page. So thinking about division of labor too, being able to compare Persian workshops with those elsewhere in Europe at the time, for example. And really thinking again about how with the naked eye, some of these areas really do look flat in person. Students thought about how you would encounter the page, a time before electricity, how the gold would interact with the light, especially with flickering candles. And so it really brought the page to life in ways that sometimes the original page hasn't been able to do. Information about pigments is another thing that's been coming up with an increasing number of chemistry classes, material science classes. And so being able to see more about the chemical properties of these works. With this blue, for example, we had hoped it was lapis lazuli, very precious, expensive material. Probably not. And so being able to see that a way that it performs, maybe it's azurite, maybe it's something else. But so learning more about the page and what went into it through the artistic process. So Amber's going to tell us a little bit. She selected the images for the class. So about the selection process for teaching, and also why we use still images and recorded videos.
Absolutely. So we use these still images to kind of complement not only the high resolution images, but also the actual physical object. A lot of these, in one of our next slides, we're going to show some videos that were actually used inside the galleries. But we use a combination of these views to really emphasize certain details. On the right-hand side, you can see one of them is in black and white. You're able to kind of diffuse the color completely in order to emphasize the line detail, which in this frontispiece is incredibly important detail to see how the artist actually used line and used value to create these works. We're able to specularly enhance the object, which, as Liz was saying, kind of makes it look three-dimensional, which is such a fun detail. But seeing the paint density is important also to learn about process. Which paint was applied first? Which color was applied first? Was the gold applied on top? A lot of these times, these stills give us more questions than answers, but it gives the opportunity for students to kind of embark on their own research, which is incredibly exciting to see what questions they have. And in the next slide, we actually have a video that I was able to use with a couple classes in a public program. But this video allows you to better see kind of what the RTI viewer looks like. So after the images are taken, they're kind of downloaded into this software. And this is the object file that comes out. So a lot of the times we'll take videos like this one or screenshots. But this particular work, which is a flower study from the Mughal period in India, we were able to use it 2 different courses just this past semester. The studio course, Tasvirkhana, which Liz was talking about earlier, in a chemistry course that focused on an introduction to material chemistry. And as I mentioned just a few minutes ago, we were able to even integrate some of these into a public program that we had earlier this semester. We're able to see details of the composition, but also the process of making, which for the studio course was incredibly important because our first assignment, and again, I was the teaching assistant for this, so this is really helpful for me as well. The first assignment was actually to copy and select one of these flowers to recreate. So these flowers in person appear to be less than a square inch large, and we had to recreate those in a 2 square inch cube. So really trying to hone in on the details that the artist is creating. Students had questions about the pollen or the details on the petals, and we were actually able to view the RTI file within the gallery and being able to compare the views of the RTI with the physical object. And students kind of coming alive, almost being like, oh my gosh, I did not realize that leaf petal went over the stem, or that the color had such a range in the petal, because we're really focused on rendering and line detail for our first assignment. It was kind of this beautiful introduction. But also emphasizing, as we said earlier, that this wasn't a substitute for the object, but a complementary process that proved very important for our artistic exploration. And we were also able to use this for our chemistry course, materials chemistry. So they had questions about the actual material, the paint, but also the paper. And RTI allows you to view kind of the raking light of the object. So seeing that, oh, the paper is exposed, or the paint is covering the paper in such a way that it's not necessarily primed all the way through. And seeing emphasis or seeing examples of wear on the object. So you can see in the top left or top right flower, you actually see some white areas. That's where the paint has flaked off. So students were really curious of what binders were being used in the paint, what caused that kind of wear. And we're actually able to integrate some of that data into TMS under our conservation section.
TMS is the museum's catalog. We are also working with our library staff on how to integrate these models into other catalogs in campus, as well as our digital archives to make them more usable for students. Those of you with sharp eyes will have noticed that this is a desktop application. And one of our critical issues at the moment is figuring out accessibility for this. So a lot of times we are sharing it through a screen share and manipulating it in a remote class, also using videos like the one we just showed you, or screenshots. But our goal is really to make that more accessible in the long term. There is a web RTI viewer, but it's not actively maintained. And so we would love to hear about any leads on sustainable web browser interaction, especially if it handles the specularity in addition to the raking light. But again, this is a free piece of software, and it's a lightweight piece of software. So it isn't a big deal to have a student download it, especially if they will be using it for multiple class sessions. Hold on, there we go, okay. Again, where do we bring students in and how? With RTI, because the model is interactive, there is a sense of play in making, even just in exploring that. Those models. So that's fun in itself. And then again, prompting questions that the student might follow up in other ways through research, through more observation, through comparison. But this is also one of those where we feel like the impression publicly of RTI is, it has a much higher barrier. People are more familiar with photogrammetry and with 3D models at this point than they are with RTI. They often only perceive RTI as published parts of scholarship if they've seen it at all. And it's actually a much faster and in many ways easier process than photogrammetry. It requires much less computing power, and it's so much faster. So what you need for RTI is a source of light that is directional. We use a studio light with barn doors, but you could even use a flashlight if it were a small enough object. You need a shiny black sphere. You can use a billiard ball. You can use a marble. You can use a ball bearing spray painted black. And you need a camera that can be held stationary in a parallel plane to the object. The software to build it is free. And again, very lightweight. It's also open source for your own modifications. And that gives us a lot of places to bring students into the processes of creating, of building models, of changing models, even potentially at later dates of exploring the algorithms that are behind this kind of work. What are the fitting algorithms that are used to calculate the angles of light that go into this? So again, possibilities for bringing students in who aren't just in art history classes or other classes that are using objects, American studies, things like that, but really all the way across the curriculum. I've been talking with folks in our math and comp sci departments about some possibilities here. We have a document, that same document that Amber shared earlier also contains a section on the basics of RTI. And again, this is something where you could quite easily hand it to a student as an independent study project with very little support needed. There are great resources online for tutorials on how to do it. And then I will add that we're happy to answer questions about what worked well and what didn't work well. We have some suggested objects for getting started in this document as well. Now we're working, again, data exports, bringing people in on the algorithmic processes, other kinds of cross-campus collaboration and cataloging.
So what's been exciting too is, as Beth has mentioned, we're often doing more than one type of imaging for the same object. So for example, this is a Chinese Buddhist bronze in the collection. It's pretty much shown to scale as it is on your screen. It's quite small. It was a good first object for us kind of early on in photogrammetry. But this is something where we have photogrammetry and RTI. This was one of those objects where it hadn't been used much. And so I've been using it more for teaching in the last year. As you can see on the left, in the very bottom there on one of the legs, there's an inscription. We have no translation of this in the file whatsoever. And it probably has a lot of information. If this is a Buddhist votive bronze, it might even tell us who donated it, when, maybe where. So this will help us answer a lot of questions about the object, which then helps us teach with it far more effectively. So, when you're doing those 100 to 200 photographs of an object as it spins around on the turntable, you start to notice these details. And so seeing the inscription go by and by and by, we were getting really curious about what does it say? So I was able to send the model and RTI still images, like you can see in the middle and right, to a range of different scholars on the Williams campus. And they in turn sent it out to scholars all around the world at a time where we weren't really able to support many visits to the museum on site. It was mainly, again, for teaching purposes, for classes. This was an excellent way to, once again, also be able to reach a far wider audience of specialists around the world. And so by sending these, asking for help for the translation, and, as part of an ongoing study of objects in the collection, even once they're here, there's still so much more that we can keep learning about them. And so trying to use models to help us learn, but also to help improve the collections data that we have. Something next on our docket is thinking about textile fragments, doing those more, especially for RTI, to learn more about wear and techniques of production, and even connecting with special collections on the Williams campus. Again, thinking about, for many of us colleges, there might be gifts by similar folks or similar types of objects in a range of different places. So having, special collections, the museum, different departmental collections, professors' collections, being able to kind of come together as well too.
I'm showing here one last object where we did both photogrammetry and RTI. And actually both of these were produced with the object installed in the galleries for an anthropology class this spring. And this is just a reminder that photogrammetry is about scale and spatial orientation, how objects relate to the whole, parts relate to the whole. In this case, a lot about what you could see from different angles. When you have an architectural fragment, where is it visible from and what can you see that way? Where the RTI is showing us things more like the quality of the stone, what is it made out of, how are tools used on it, what are the wear patterns and damage, so we can explore stories through that lens as well. So different entry points to show us different aspects of the same object.
We also have very few records about this object. So photogrammetry and RTI, like with the Buddhist bronze, really help us answer questions about this object's provenance, its historiography, including its original placement on a Maya temple or palace facade around the year 600, and for how long it was buried until Williams students in the Lyceum of Natural History claimed it back in 1870. So it's been on campus since 1870. We have 2 lines in one of those students' books about the expedition. It was an unplanned expedition. We have another object that was taken at that same time. We don't know if they belong together. Stylistically, they seem different. All that we have are really the objects themselves. And so being able to work with our Maya specialist on campus, Antonia Foyas, who's in the anthropology department, working with geosciences folks. I've been in touch over the years with different object conservators at the Conservation Center. Just what can we tell looking at fossils on this, the limestone itself, as you can see on the right, these layers of stucco and red polychrome. What can we tell from the object, and being able to share these models with folks really, again, around the world to try to learn more.
So what's next? And after this slide, we're going to be throwing it open for conversation, because we'd really love to be hearing from you all about ideas about what you're already doing or what you think we should be doing, where we can all work together, and how this might relate to other resources as we expand. We're continuing to create models. We started out with ones we thought we should do, and now we have a request list that is going to take us all summer and then some. This is one of those things where when I started talking to people around campus, they're kind of like, that sounds interesting, but I don't really see a use for it in my class. And then as soon as they see the model, all of a sudden the ideas come pouring in, where people really need to see examples of it in practice before they get how it might be useful in their own teaching. We are continuing to think about linking these across campus and making them accessible in multiple places, not just as finished models, but as data sets and as opportunities for students to do their own projects. So finding all the models, but also finding the photos, and that also enabling reprocessing the same models later as software gets better. We are really, really trying to figure out how we can expand access to RTI, especially as we're using it more and more on understudied objects in our collection. We have a whole lot of things where you have question marks. And part of the problem is we don't know a lot about them, but there's also this piece where we just need people to pay attention to them. We need people who are interested, who want to contribute. We have 15,000 works in our collection. Most of them will never fit in our galleries for a variety of reasons, whether that's their condition or because they're fragments that don't really speak well on their own, or just because we only have space for about 250 objects at a time. So filling in a lot of these gaps and making more of our collection used. We've also been thinking about how do we work with other imaging and modeling people across campus. Corey Campbell had to jump a few minutes ago, but he has been working with us on how this might relate to projects in GIS and landscape discussion. So how might we think about objects in space in different ways? And then more kinds of teaching. How are we using these through the libraries, but also directly with faculty in a sort of a full cycle of communication. And then, of course, this is the perfect spot to say we'd love to be collaborating more with other colleges on approaches, but also on research opportunities and best practices and the general infrastructure that goes into these projects. And with that, I will stop screen sharing and encourage you all to jump in.
Thank you all so much. That was an excellent and fascinating talk. I'm just full of ideas and very excited about all of it. But I think just to kick off the discussion, please write conversation, ask questions in the chat, or you can raise your hand and I can call on you to facilitate the discussion. But I'll just say that I think you made, Beth, at the outset, you said you really believe that the making of digital resources is, or at least should be, a large part of a liberal arts education. And I feel like you guys made that case really effectively. That's really inspiring stuff.